on the partial fraction practice page, number 6. Caveat. Number 6, I meant to be this integral, and so I'm going to do it, and then I'm going to do the one on the page. I meant it to be x to the third plus 1 over x squared minus 4. I meant it to be this, and if it was like this, the degree of the numerator is bigger than the denominator, so you would need to start with long division to get the numerator reduced. So we would go x to the third plus 1 divided by x squared minus 4. X squared goes in x third. It would be that times x would make x to the third. Multiply all this by x, and we'd get x to the third minus 4x. And then when you're doing division, you would subtract now, so you could change the signs, and now it's an addition problem. These turn to 0, and we get 4x plus 1, and then we'd have, that's a remainder because x squared wouldn't go into it, so we'd put 4x plus 1 over what we were dividing by, x squared minus 4, and this problem would become the integral of x plus this thing. So I'm going to split that to dx plus the integral, the antiderivative of 4x plus 1 over x squared minus 4, which factors to x plus 2 and x minus 2. So the integral of x dx is just 1/2 x squared, and so we've taken care of that. This we would split into two integrals, so it'd be plus the integral of a over x plus 2 plus b over x minus 2 dx. Now we need to figure out what a and b are. And so just momentarily, the common denominator is x plus 2 times x minus 2. So this one would have to be times x minus 2. This one times x plus 2. And so we would have, we're trying to get 4x plus 1. And so we have x's and constants. So x's give us, there are 4 of them here, would have to equal ax's and plus bx's. So a plus b has to equal 4, and then the constant would be 1 has to equal negative 2a plus 2b. Now, if I look at this, I think I can multiply the first one by 2 all the way across. The 2a's would cancel, so I'd get multiply by 2, that's 8 plus 1, 9 equals, the a's would cancel out, and I'd get 4b. So b equals 9 divided by 4. And if b equals 9 divided by 4, which is 2 1/4, a would have to be 1 3/4, which is 7 quarters. So to finish this integration, we'd have the 1/2 x squared plus a constant, 7 quarters that would pull out, times ln of x plus 2 plus, and this one, and to get this, if you're having trouble, you would let u equal x plus 2 and do the u subs on this, and you would come up with that. And u sub on this one would u that equal to x minus 2 for this part. It comes out to be 9/4 ln of x minus 2 plus c. So there's the final answer for the antiderivative of that. However, that's not the problem I put on the page. On the homework, I actually said do the antiderivative of x to the third plus 1 over x to the fourth minus 4. So, if you were actually to do this one, this is a degree less than this one. So you would do, it's already less, so you would factor this. And so it becomes the derivative, or the antiderivative of this. Factors. So x to the fourth minus 4 factors to x squared plus 2x squared minus 2. And to do this with partial fractions, you would have to factor this one, 2x plus the square root of 2 and x minus the square root of 2. So we would get, these are linear factors, so I'll just put a over x plus the square root of 2 plus b over x minus the square root of 2 plus, this would be a quadratic factor, so I'm going to go cx plus d over that quadratic factor, x squared plus 2. Now, so this one would have to be multiplied by this and this. So that's quite a bit. We're going to get x to the third. We're going to get minus square root of 2 of x squared. We're going to get plus 2x. And we're going to get minus 2 square root 2. That's what a would have to be multiplied by. B's common denominator would be, we'd have to we have this, we'd have to have this and this one. So we'd have x times x, x to the third. We'd have square root of 2 times x squared. We would have 2 times x. And then we'd have plus 2 square root of 2. Fortunately, the last one is a lot less. It's just these two multiplied, which came from that, so it's just x squared minus 2. All right. So now to do, I'll do this in red so we can tell things apart. So we have x to the thirds, x to the seconds, x to the first, constant. Over here we have 1x to the third, 0x squared, 0 x's, and, excuse me, 1. And on the other side, the x to the thirds, excuse me. So we have ax to the thirds, ax to the thirds, we have bx to the thirds, and we have cx times x squared is cx to the thirds. And that's all the x to the thirds we have. X to the seconds, we have minus square root of 2a plus square root of 2b plus x squared, so let's see, dx squared. X's, we have 2a plus 2b and x's minus 2c. And then we have the constants. We have minus 2 square root of 2a plus 2 square root of 2b. And then over here, the cx will not make a constant, but the d times that minus 2, minus 2d. So that got a little crowded, but now I'll pull out my calculator, if I can find it. There it is. And we do second matrix, edit, 4 by 4. We have 1, 1, 1, 0. I already have that in. We have minus square root of 2, that's that. Square root of 2, 0, 1. We have 2, 2, minus 2, 0. Minus 2 square roots of 2, 2 square roots of 2, 0, minus 2. That's what I have in. Let's see if I got that in for second matrix. B, edit, by the way. Oop, that's A. Second matrix, edit B. I have 1, 0, 0, 1. That's correct. So second quit. And we go matrix A, inverse, matrix B, enter, and so we get A is equal to 0.1616-ish, B equals 0.3384-ish, C is equal to 1/2, and D is equal to -1/4. And now comes the fun. Okay. That's the linear one. So the antiderivative of that's just going to be ln of that times A. So we're going to get 0.1616 ln absolute value of x plus the square root of 2. B's over a linear, so that's just going to be ln, and it'll be the constant, so it'll be plus 0.3384 ln absolute value of x minus the square root of 2. But this last part, I can put the cx over this and the d over this. So I'm going to split this into two integrals. So we're going to have the integral of cx, c is 1/2, which I can pull out, x over x squared plus 2, plus, and it's because the plus on this is in the numerator, I can split it. And the second part is -1/4 that I can pull out, and it'll be, that's the d, so it'll be leave 1 over x squared plus 2 dx. And this, if you do a u sub for x squared plus 2, du equals 2x dx. If you solve for dx, you get du over 2x, and that x will cancel the x in the numerator, and the 2 will come out, so we'll have 1/4. The antiderivative, the x's cancel, and I get 1 over u, which is 1 over u du, which is going to be 1/4 ln x squared plus 2. So that one wasn't too bad. This one, so we have -1/4, and this, if I look at my table, and I'm going to give you my first look at, I'm going to add all the ones that are in the appendix in the back of the book to the ones I have on my sample test, and you'll have all of this as formulas to back you up. And this looks a lot like that, where x squared is the u squared, the a squared would be the square root of 2 squared, so a is the square root of 2, and u is x, so I'm going to use this formula, and I'm going to get 1 over square root of 2, the square root of 2, let's see, where'd it go? arctangent of x over the square root of 2 plus c. And so there's the antiderivative of the actual problem I put on there. This was a lot more difficult than this. This is more like when I might put on the test. Something that's this straightforward, okay? The top of this. Okay, moving on. Now let's do some trig sub. Now some of these I might be able to look right here and find them, but if I got to demonstrate trig sub on the test, you need to go through the process of doing one of these. So let's take a look at 7. And that's the antiderivative of x squared over 9 minus 5x squared dx. So this is a subtract. It's something, a constant minus that. So if we make the triangle, this is the big one, so that has to be 3 that goes on the hypotenuse. And when it's subtract, we're doing a sine, cosine, or secant. A sine, tangent, or secant. Let's see here. I believe that's the sine, which means we're going to have to put over here the square root of 5x, so that this side becomes the square root of the hypotenuse squared minus the leg squared, and square root of 5 squared is 5, and x squared is x squared, so 5x squared. So letting the sine of theta, I've got this off the page there. Make sure I apologize. There we go. The sine of theta would equal square root of 5x over 3. If I take the derivative, I get cosine of theta d theta equals square root of 5 over 3 dx. So I have a replacement for dx if I move this over. So dx would be equal to 3 cosine theta d theta over the square root of 5. But I also need an expression for this, and I could go with this or with that. I'm going to go with this. Simpler. So this would be adjacent over hypotenuse, so that's cosine theta is the square root of 9 minus 5x squared over 3. But I need just an expression for that thing, so I'm going to multiply both sides by 3. So 3 cosine theta equals the square root of 9 minus 5x squared. This doesn't have a square root on it, so I'd have to square both sides to have something for that. So now I think I have everything I need. It may not be pretty, but this is what we're going to do here. Well, I guess I don't have everything I need, because the first thing I need is an x squared. So I have to solve for x. So I have to multiply by 3 and divide by the square root of 5. And so I have 3 sine theta divided by the square root of 5 is x. So x squared would be 9 sine squared of theta over 5. So I squared that. The denominator would be 9 cosine squared theta. The dx is 3 cosine theta over the square root of 5 d theta. So what does this simplify to? Well, the 9's will cancel, and the 3 over the square root of 5 times 1 over square root of 5 can be pulled out, so that's going to be 3 over 5 square root 5 antiderivative. Now we have sine squared theta, and I have a cosine squared and a cosine, so the cosine will cancel one of those, so it'll be cosine theta d theta. So this will be 3 over 5 square root of 5. We could call sine squared 1 minus cosine squared theta over cosine theta. And then we could split this up. This is different than I did it in class. What I did in class was I said sine squared, and this is I could think of this as sine squared theta times cosine to the cosine theta, not inverse, so to the minus 1. I don't want to put it there because that makes it look like inverse. And if I use that formula, I could go to either 11 or 12. And I want to look at those carefully. 11 will take sine to the m, cosine to the n, and reduce the integral part so cosine gets 2 less. Well, if it's already minus 1, I don't want to go 2 less than that. So, when I look at 12, it will reduce the sine by 2. Well, sine reduced by 2 would go to 0, and so then I just have the cosine to the minus 1, which is secant, and then I can use the secant formula. That's what I did in class. I'm going to do this here, and it'll give me the same thing, and it'll be a little bit simpler. 3 over 5 square root of 5, antiderivative of 1 over cosine, which is secant theta. And then I'm going to have minus, and I'm going to have cosine squared over cosine, which just is the integral of cosine theta. And this becomes 3 over 5 square root of 5. The antiderivative of secant, using number 5, is ln secant x plus tangent x. So ln, absolute value of secant theta plus tangent theta. And the antiderivative of cosine is sine plus c. So this becomes, now we've got to get the thetas out of there. We have 3 over 5 square root 5. That's times all of this. So times ln. And now to change back, we look at our triangle. There's theta. Secant would be 3 over that. 3 over square root of 9 minus 5x squared plus tangent, which is that over that. So they're both over the same thing. So I could go 3 plus square root of 5x over that denominator minus the sine of this is square root of 5x over 3. Okay? That was 7. Hopefully 8's not as messy, but we will soon find out. That was the antiderivative of 7 over x square root of x squared plus 16 This is a plus square root. That's kind of telling us that we want to use the tangent substitution. We want to put, in other words, we want to put square root of x squared plus 16 on the hypotenuse. That's where it gets the plus. And we put the x here and the 4 here, so that becomes leg squared plus leg squared. Square root is the hypotenuse. So the tangent is 4x over 4. And if I take the derivative of this to get a replacement for dx, I get secant squared theta is the derivative of tangent theta, 1/4 dx. Okay? And let's see, I need the square root, which I can use with this or this. I'm going to use this one, and that would be the secant of theta is a hypotenuse over the adjacent, or if I just need the square root thing only, I'm going to have to go 4 secant theta is that square root. And let's see, I need to know x. So I can multiply both sides of this by 4 and get 4 tangent theta is x. So this becomes, 7's a constant, that's times all this, so it pulls out. That leaves a 1 in the numerator. The x is 4 tangent theta. The square root is 4 secant theta. And the dx is 4 secant squared theta d theta, having to multiply both sides by 4. All right, so now we'll do some simplification. These 4's would cancel, so I get a 4 coming out, so I get 7 4's. And then I have antiderivative. One of these secants is going to cancel, so I'm going to have secant over tangent. And that's not something, one of them is the derivative of the other. So I'm going to go to sines and cosines. So tangent is sine over cosine, which would put the cosine in the numerator. Or, if you will, 1 over tangent, cotangent, which is cosine over sine. And then we have secant, which is 1 over cosine, d theta. So the cosines cancel. So I'm left with 1 over sine, which is cosecant. And my table says the cosecant is ln of cosecant x minus cotangent x. So we got 7 4 ln cosecant x, theta, what's that, minus or plus? Minus cotangent x plus c. Now I need to change it back, so I get 7 4 ln cosecant is the reciprocal of sine, so instead of x over this, it's that, square root of x squared plus 16 over x minus cotangent, which is not tangent, x over 4, but 4 over x. So that's over x also, so I can just put minus 4 over x. Okay, so that one wasn't too bad. Still takes a while to think through all of those, so you really need to practice these to be able to get done with the test in time. Okay, number 9. Hopefully I got enough room here. The antiderivative, 11 over x to the third square root of 4x squared minus 16 dx. So this is an x squared minus 16. This is not a sign, because that becomes the constant minus the square. We got the square minus the constant. So we need to do a little bit different. That is got to be the long one, which goes on the hypotenuse, so it's got to be 2x on the hypotenuse. So we do the 4 on the, if we're going to do secant, we put it here, so that the secant of theta is 2x over 4, which is just x over 2. And so we can now then multiply by 2, we get 2 secant theta equals x. And if I do, I'm going to slide this under there. So if I take the derivative to find out what dx is, it's going to be 2, the derivative of secant theta is secant theta tangent theta d theta. Oops, got a little tight there. And I need an expression for that. And that would be here, because it would be the hypotenuse squared minus the leg squared would be the other leg squared. So an expression for this, I could use it with that one, but I'm going to go here, and that would be opposite over adjacent, so we get the tangent of theta is that square root over 4, but I'm going to put the 4 over here because I need the square root thing by itself here. So this now becomes 11 pulls out, 1 x to the third. Let's see, that would be 2 to the third secant to the third theta. That's my x to the third. And this is 4 tangent theta. And my dx is 2, this is times, secant theta tangent theta d theta. Fortunately, quite a bit of this cancels. The tangents cancel. The secant cancels one of these and makes only secant squared. The 2 over the 8 is 4, which I can pull out with this other 4, so I get 11/16 antiderivative, nothing left in the numerator except d theta, and in the denominator I have secant squared theta. Well, secant squared, if I move it to the numerator, becomes, since 1 over secant is cosine, it becomes cosine squared. So I got 11/16 the antiderivative of cosine squared theta d theta. And pulling out my table, there's a formula for cosine squared. It does a half-angle substitution is how you get this. So it comes out to be theta over 2 plus 1/2 sine of theta cosine theta, all of that plus c, and all of that is times 11/16. And now we need to change back to x's. So we have 11/16 theta. If we were to solve for theta here, we'd have to go arc secant of both sides here. So we're going to get arc secant, or secant inverse, of x over 2 divided by 2. Actually, there's a half in both of these. I could bring it out and make it just 11/32 and not put the halves in here, but I'm going to put it in here. So there's theta over 2 plus 1/2 sine of the angle, and the sine of the angle is that over that, so that's square root of 4x squared minus 16 over 2x, and the cosine is adjacent over the hypotenuse. These are times, so I'm not doing common denominator, so I'd actually get an 8 on the denominator, but the 4 would cancel these two, so it's just 2x squared, and that in the numerator plus c. And that's good enough for me. Okay, that takes care of those. Once again, a reminder, you'll get all of these formulas on your test. But you will need to show me how to do trig sub on at least one of the problems I give you. And that's probably the longest, although sometimes integration by parts can be pretty messy. I will try not to give you a long one of those. Okay, that's the homework.